All right. Hello, everyone. Welcome back to Comp 3430 Operating Systems. I hope that you all had an excellent weekend. It was pretty busy for me and my family. It was Mother's Day on Sunday, so there's lots of Mother's Day stuff going on. We also went to Science Rendezvous on Saturday. I don't know if anybody was volunteering there. Was anybody volunteering? Yeah. Okay, awesome. It's a lot of fun to go. They do this every year. They canceled it last year, and then of course they canceled it for those 3 years that nobody wants to talk about anymore. They had it back on this year, and it was a good time. It's for kids. It's for kids, and it's like lots of fun science and engineering and math and that sort of thing, like activities for kids to come and do. And it's a good deal of fun. And my kids are finally old enough to like meaningfully engage with this stuff. So it was really fun to come out. They had a station where they have like a tiny little swimming pool. It's got bubble solution in it, and then hula hoops, and they lift the hula hoop up and like you're inside of a bubble. And then they've got oobleck station, which is like non-Newtonian fluid, which is just cornstarch and water really, but it's like you run across this thing because it's a giant vat of this stuff. And my kids had lots of fun with that. I hope that you all had a good weekend. What I want to do in today's class is a few different things. By the end of today's lecture, what I want you to be able to do is describe the data structures used to represent files and directory as is seen in Unix. So I'm looking at this from two different perspectives. One is like be able to describe the idea of a hierarchical folder structure. That's one idea that I want you to be able to describe in the context of this. The other that I want you to be able to describe is going to be the ideas that are in the VSFS and then thus the ext2 file system. exFAT is not a Unix file system. It is not a Unix file system in any way, shape, or form. It is a file system that has really been driven by DOS originally. So like a long time ago, it's driven by DOS. And then now it's driven by Windows in terms of the structures that we're looking at in this file system. VSFS is like this fake made up file system that's in our textbook, but it is so close in its ideas to ext2, which is an actual for real file system, that I'm going to just say they're the same thing. They are effectively the same thing. I want you to be able to describe some of the data structures that are used to represent files and directories. And so the major keyword here is inode. The major keyword here is inode. But today what I want to do is spend some time taking a look at ext2 itself. So VSFS is in our textbook, and then we're going to step into taking a look at ext2 from a practical perspective. So I want to spend some time glazing everybody's eyes over by looking at hex code for quite a while, basically spelunking in a file system using a hex tool, using some documentation as guidance to help get us to different locations in the file system itself. And then I want to spend some time writing a little bit of code, because everybody's eyes will glaze over when we're looking at a hex dump output. But taking that idea and then doing it in code, I think, is a meaningful transition to make from taking a look at this hex stuff. I want you to be able to describe how a specific file system is implemented. And I want to be clear about what the limits to this are. So exFAT, I want you to be able to describe. Just in terms of like the data structures that are there, we spent a lot of time in the last couple classes looking at the data structures that are in the exFAT file system. I want you to be able to describe how this kind of like VSFS/ext2 file systems are put together, but the limit ends at the textbook for this. I'm going to be describing some stuff about ext2 in class today that is not in the textbook, and I don't care if you know about that stuff. I'm doing this as an illustrative like exercise going through the idea of the data structures in this file system. But as a good example, in ext2, there's a data structure that's called the block group descriptor, which is not in VSFS at all. It's not at all in VSFS, and we don't need to know about it. We're going to need to know about it for today's lecture, but I'm never going to ask you a question about block group descriptors in ext2. This is not something that I'm going to ask you about. So in terms of describing how a specific file system is implemented, The end is at VSFS. That's about as far as I'm thinking about here in terms of the data structures that are there. I want you to be able to show how common file operations are performed in terms of manipulating or working with a file system's data structures. So we went through examples of like, here's a file that I want to be able to open in exFAT. What data structures do I have to be able to refer to be able to do that? In terms of VSFS and ext2, I want to accomplish the same task today. So I want to go through these structures that are things like the superblock. The superblock is effectively the same thing as the main boot sector. I want to be able to go through inodes. Inodes don't really have a synonym in exFAT, except they're kind of hand-wavy, sort of like directory entries. Kind of hand-wavy, sort of like it. And then there's directory entries, which are not at all like the directory entries that are in exFAT, but they are part of the file system's data structure that we're looking at here. We're also going to talk about two important data structures related to this file system that are called allocation structures. And allocation structures are used for us to be able to say things like, this has been used or it has not been used. This data structure partially exists in exFAT. So there's one directory entry type that's called the allocation bitmap directory entry. This structure is effectively the same as the thing that we're going to talk about today in terms of VSFS. Thank you to everyone, by the way, who emailed me last week to say that the audio cut out on the live stream that I was doing. I appreciate that you email me. Unfortunately, and really painfully for me, I don't see my emails until after class, until after it's already happened. So if you happen to be like outside class watching the live stream and you know somebody in class is in class right now, and if you can come communicate with them and like say, hey, raise your hand and say there's something wrong with the audio, I really appreciate it. Because I want to make sure that you have like recordings of the stuff that we've done in class. And I went and I made re-recordings of the stuff from lecture 4, and it's painful for me to have to do that. But I also never go back to the live streams and watch them because I don't know if any of you have ever listened to your own voice for long periods of time, but I don't want to do that. I really, really don't want to do that. So I appreciate that you're emailing me, and if you can, if it's possible, please try to let us know during class time that it's happening. And with that, the first thing that I promised to do today and this week is to give you a chance to ask me some questions about assignment 1. I'm going to leave this up for a couple seconds, and I'm going to just quickly pop over to the course forum while you are all filling this in. Okay, I'm going to pop over to the course forum because I want to call to attention a couple things. One is that I made a couple of updates to the assignment 1 template files. They are not functional changes for you. I've changed the name of the program that's called LS because unfortunately on Aviary, the way that it is set up is that when you have a program that's called ls in your current directory, it overrides the ls command to list the contents of the current directory. And so if you make the contents of this template repository, and now there's a program called ls in your current directory, and you type ls, there's no output. There's no output. All your files are still there, there's just no output. So I changed the name of this file to nqpls instead of just ls so that it doesn't conflict with the ls program anymore. The other thing that I've done is I made some changes to the way that ls.c produces output, and it calls the nqp-vol label function. This is something that I want to make sure that you can test with this code, so I've updated that. If you've already got this template on your system, then you ought to be able to just git pull and get these changes from the remote repository. If you don't have it on your system already, then you should just be able to clone it for the first time. The one thing that I did want to raise to your attention, and I'm not going to answer this question from 4 minutes ago during class. Oh, it's not a question, it's just a follow-up. Is this post right here? So Aiden, thank you for posting this. Your name's right there, so I hope you don't mind me calling you out in person. But Aiden replied to himself here and put a link to these documents here. So this is on a website that's called elmchan.org. either way, thank you for sharing them with us. And now I'm sharing them with all of you. So if you want to find another resource that describes some of the structures that are in EXFAT, either find it in the CS Discord or find it in the course forum. This looks like it's a pretty good resource to work with. So I'm going to pop over to my Mentimeter here. And I'm going to try to answer some questions. All right, so I'm on my 5th attempt at the assignment. Could I give you some checklists on some type of checklist on how we should go about the assignment, how we can test while coding each function? So I guess I might need to ask for clarification on what you mean about a checklist specifically. But what I will point at, I think, and please try to raise this to me if I'm not interpreting this correctly. I'm going to go back to the description of assignment 1. And I specifically want to go to the bottom of this document where the evaluation and the rubrics are. What I've tried to encode in these rubrics really is like me actually going through and building this stuff up. Like these are the stages that I got to as I was implementing all of this stuff. So when I was implementing NQP mount, for example, I tried to make sure that I was minimally able to check to see if this boot signature field is the valid thing that it's supposed to be. I think it's like AA55. I think that's the value that it's supposed to be. That was the first thing that I checked, and then I proceeded with the other checks. So file system name, the must be 0 field in the first cluster of root directory. I made sure that those things were valid before I proceeded to anything else. For this function, the assessment here is going to be a visual assessment on the part of the graders. I'm not going to make bad file systems and then have them run your code with bad file systems. I'm going to have them look at your code and see, did you check to see that boot signature field is what it's supposed to be? Have you checked with a loop that all 53 zeros are in fact 0 before your function has returned? So like in terms of the mount function, that's kind of how I approach this thing. In terms of the open function, it's kind of the same idea here. So when I was implementing this, when I was building this, the very first thing that I did with open was to find a file that's in my root directory. And that's all I did. Like I stopped at that point to like proceed with other things later. But I have a volume where the cluster size is big enough that the whole root directory is contained within one single cluster. And this is the one file.image volume that I've put into that volumes repository. And the only file in that root directory is called readme.md. So this is also something that fits within one single file name directory entry. So I tried to make sure I could get to that file. There's no output at this point, but I'm able to like use my debugger to step through and confirm that I'm able to find that specific file in the root directory. At that point, then what I did was to use something like one of the nested directories volume. So like I've built up this nested directory structure. Am I able to get to subdirectories? Am I able to go from the root directory to another directory that's in some other cluster location? Am I able to then go to a point where I have directory entries that are not fully contained within a single cluster? So this is the case where the cluster size is much smaller. There's one of the volumes that I've given where the cluster size is the same as the sector size, so 512 bytes. And so I'm trying to start with like the easiest possible case for me, which is readme.md is in the root directory and there's nothing else in the root directory. So I should be able to find that there and then build upon that by looking for subdirectories and then build upon that by looking for the next cluster in the chain and kind of building up stuff that has to use the FAT. The NQP read function is the same sort of idea. I want to be able to read something that is going to be a request size that's less than the size of a whole cluster, and the file is entirely contained within a single cluster. And then I want to build upon that to be something that's going to be more than one cluster. And then I want to build upon that to be something that's going to be scattered across many different clusters, and I have to go through and build up the cluster chain for this thing. In terms of testing, I guess what I'd say is look at the volumes repository itself, and I've tried to make volumes that cover everything that's in this set of rubric descriptions. So like making sure that you can meet all those different things. If anyone's willing to confirm, like thumbs up with the checklist answer, have I given you an idea of what I'm looking for in terms of checklist idea? Sort of, sort of, sort of. There's some yeses and some sort ofs. Okay. What does a header file mean by mount and unmount the file system? Where do we put it, if anywhere? So when you're doing the mount and unmount operations, I'm going to go to assignment 1 template, and I'm going to take a look at nqp.io.h. The mount function here, what I would probably suggest you do is have a file scope variable that represents the file descriptor for the volume that you've been asked to mount. So like do the checks, and then if it succeeds to check it, then set this file descriptor at the file scope to be that file descriptor, so that when I call open and read and so on, it's going to use that file descriptor. The unmount function doesn't actually really need to do anything. You could close the file, I guess, but it itself doesn't do anything other than check to see that you've called mount previously. So the file scope file descriptor has a value that's not something like -1. What's the use of the no fat chain field? Okay, that's a good question. So I'm going to pop over to here, and I'm going to go back to the group here, and I'm going to look at the volumes. The no fat chain field is a case like this one here. So this is one big file.image. This volume has a single file on it in the root directory that's called picture.jpg, and that's the only thing that was ever written to this volume. That means that all of the clusters were free when I wrote this thing. So every cluster was free. The no fat chain fields, and I'm gonna come to you in just a second, but I'm gonna also open up this exfat document that we were looking at here. And in this contrived example, we had image.jpg here being a cluster chain that starts at cluster 8 and then proceeds for many clusters. The no fat chain field says that if you start at cluster 8 here for image.jpg, you don't actually need to build a cluster chain for this file because all the clusters are right next to each other. They're all literally beside each other. So it's 8, 9, 10, 11, 12, 13, 14, 15, 16, up to the size of the file. And so that means you can just read through those clusters without having to go through the process of building a cluster chain for that thing. Yeah. Okay, that's fair. So the point being made here is that files that occupy only one cluster will also have the no fat chain bit set. One other thing to note, thank you for adding that, but one other thing to note is that if the no fat chain bit is set, then the fat entries might not be valid. You might not actually be able to build a cluster chain at all for this thing if that no fat chain bit is set. So if that no fat chain bit is set, you have to respect it. You don't have much of a choice to be able to do that. What are we supposed to be checking for when making sure a file system is mounted? So there's 4 specific fields that I'm looking for you to check, and the 4 specific fields are documented here. It's the boot signature field, file system name must be 0, and first cluster of root directory. Checking that it's mounted in other places, it depends on your internal structure and how you've implemented it. So if you're just keeping the file name as a file scope variable, then checking that it's not null. If you're keeping a file descriptor at a file scope level, then checking to see that the file descriptor is not like -1 or something like that. Is the main boot sector always the first 512 bytes of the volume? Yes, it is always the first 512 bytes. Regardless of what the sector size, it's always going to be the first 512 bytes of the volume. Can we use global variables? Sorry, I didn't mean to mark that as answered, but I'll answer it. Yes, you should use file scope variables. You almost have to use file scope variables here. You don't have a choice. Specifically because of the idea that calling mount has side effects that are used by things like open and read and lseek. So they have to have that. Are we using open, read, and lseek to work with the volumes? Yeah, 100%. So I'm going to pop back here, and I'm going to take a look again at the header file. And I want to briefly describe to you what operations you would be doing in each of these things. So the mount function will have to call open internally, but not NQP open. You have to actually call open on the file name that's been passed to you. You're going to have to call read on the thing that's been passed to you. And then that's about it for this one. You don't have to do lseek. You don't have to move around the file for this function. You really just have to call open and read to be able to confirm that the thing that you've been passed is a valid file system. The unmount function, like I said, you don't really have to do anything here. You could call close if you want to, but you don't really have to do anything with the unmount function. The vol label function, this one is going to call read. It's going to call lseek. You're going to have to go to the root directory to find the volume label directory entry. And then once you've found that volume label directory entry, so it's going to be a lot of reading to go through the directory entries that are there. Eventually, you're going to return a string. The open and read functions, you're going to have to call read and lseek lots in these functions. You probably want to add functions that are going to do things like go to the start of the fat or go to the start of the cluster heap. Because you're in both of these functions, you're going to have to do that operation pretty frequently as you're going through it. Yeah.
For the label one, is it always found in the root directory somewhere there, right?
It's a good question. Is the volume label always found in the root directory? Yes. This is the only directory that can have anything that's not file, stream extension, and file name directory entries. And then the 0x00 to end of directory. The root directory is the only one that has all those special things. Yeah. And you had a question. Okay, you're good. Okay. So open, read, get dents, and open are all going to have to call some combination of lseek and read. Reading into directory structure types, lseeking to locations within the exFAT volume. Yeah. So the question is about doing an absolute offset lseek and then relative offset lseeks versus just calculating directly to the location that you want to go. The answer for me personally is that I cannot do the mental gymnastics of like calculating the absolute offset to get to a specific location. I just can't do that. I cannot do that in my head, and I find it painful to write code that does that. So my strong preference, and the question, I want to add some context here. The question is asking about lseek, where there's three options here: seek set, seek cur, and seek end. When I do things like go to the nth entry in the fat, the way that I do it is I do a seek to the beginning of the fat as one lseek, and then I will do either one or n lseeks that are relative to where I am right now. So I'll go to the start of the fat, and then if I want to get to entry 5 in the fat, I will either call lseek 5 more times, but with seek cur, or I will do 5 times whatever the size of the thing is that I'm working with. Same with the cluster heap. The way that I approach this is I absolute offset to the start of the cluster heap, and then I do relative offsets to the clusters that I actually want to get to. Yeah.
Here, so when we actually read the image itself, or we lseek around it,
yeah.
Are we supposed to replicate what a hard disk would do, like sector to sector, not cluster to cluster, or byte by byte?
So the question is, should we try to replicate going sector by sector as opposed to cluster by cluster? No, don't do that. Like once you get to the cluster heap, use clusters as the amounts that you're seeking by. Yeah. Again, it would be cool if we could do hard drive emulation, but like cool in the context of not an assignment that's due in 2 weeks after the beginning of the course, and cool in the like, that's a really satisfying thing to do, and not like someone's going to assess my work afterwards. Yeah. You're right to do that. So the question is about moving by sectors versus bytes. You still need to move by bytes because lseek is operating on bytes. But what I mean to say is that I'll have a function that's like go to the start of the cluster heap and then calculate the number of bytes that are in five clusters, sorry. So if I want to get to cluster number, I'm pointing at my screen here. If I want to get to cluster number 6, I'm going to say seek to the start of the cluster heap, which is here. Again, cluster 0 and 1 do not exist. The very first one is cluster number 2. And then once I'm at the start of cluster number 2, I'm going to calculate the number of bytes to seek to location 6 in this thing as a relative offset. Yeah. Okay. So I think I answered that question. What files am I supposed to be editing? You must modify nqp exfat.c, this file here. This is the one that you have to modify this one. You are welcome to modify this nqp exfat types. This is the one that's filled with all the exfat structures. You can add your own programs, so like cat and ls and paste and tac. You're welcome to add your own programs, but the graders are going to be using these programs as they are written to evaluate your work. So the main one that you need to modify is this nqp exfat.c. What is nqp fs types? That's a good question. So that's this one right here. This looks like a really dumb, enum to have that has exactly one value in it. And I agree, this is a really dumb enum to have. But my goal is to be able to put nqp fs ext2 after this. So for some other, not any of you, but for other groups of people that come after you, I want to be able to change the file system. And I want to be able to have them implement ext2 instead of exfat. And I don't want to have to change this header file. So I want to be able to support that. The only thing that you can have as a value right now is this fs exfat, and you can hard code that that's the only thing that's supported in yours. Will we get some sample output? So yeah, so one of the things I can say right now is that in the volumes repository, so I'm going to pop over here, in the volumes repository, so as an example here, this one big file.image, this file is in the repository. So there's a picture one big file.jpg. That's this one here. This is what the output is supposed to look like from if you were to do cat on this this file that's in the repository. I can show you examples of what the output looked like, for example, for ls right now. So if I do nqp-ls and my fingers are stuck doing ls, even though I just changed this, my fingers are stuck doing ls. The first argument that I want to pass here is the volume name. So I've got the volumes in a directory that's there, and then I'll do empty, and I want to print out what the contents of the root directory are. And that's the output of empty. If I do one file dot image, and I want to print out for the root directory, it looks like this. If I do one big file for the root directory, it looks like this. If I do long name.image for the root directory, it looks like this. And if I do, as an example, I don't know, picture fragmented, and then I do for the root directory, I get an assertion failure in my code. Okay, so awesome, yeah. Because I put the JPEG file. That's why I put the JPEG file. I want one big file. I want fragmented.image. That's what I'm looking for there. So there's lots and lots and lots and lots of files in this one. They're all really, really small numbered files. It's exciting. It's really, really exciting. The other thing that I'm going to say is if you are to do the file size has changed from 4 bytes to 5 bytes because now we're into 4-digit numbers. It's exciting. I'm going to kill this. I don't want to wait for this anymore. If I do cat as an example, so cat volumes, one file dot image, and I do /readme.md, then I get something that looks like a readme. If I do tac, so tac is going to print this out backwards. I get that as output. It's difficult to read, but it's printing out every character from the bottom of the file upwards, downwards. Yeah, bottom of the file upwards. And then the way that you need to work with I'm going to do cat, one big file, volumes, one big file dot image. And if I want to do /picture.jpg, this is going to be a binary file. I'm going to hit enter and it's going to mess up my terminal. I'm going to hit Control L, going to hit Control C and then Control L. Okay, if you find that your terminal is still messed up, you can use the reset command. So TC shell is not as smart as fish and it kind of leaves this in a really terrible state. If you blindly type in reset and press enter, it should go back to normal without having to log out and back in again. What I want to do here is I want to redirect the output to picture.jpg. And then I'm going to do two things. I'm going to say MD5sum. So MD5sum is calculating a checksum of the file. If you go back to comp 2140, you all saw hash tables, yes? So you have the idea what hashing looks like. You're taking a string and turning it into a number. MD5sum is taking a file and turning it into a number that uniquely represents that file. That's the checksum of the file if you were to run this with MD5sum, and the actual contents of picture.jpg is that file. So it's that file that I put into the repository itself. I will do my best to remember to put this up on the README for the volume so you don't have to constantly copy picture.jpg to your local machine to try and open it, because that's going to be painful to try and do that all the time. Do I use fopen or fread? I would recommend that you use read and open as opposed to fopen and fread. I'm doing this all with the low-level system calls open, read, lseek, as opposed to fopen, fread. I'm going to say that you're welcome to use it, but if you run into problems, I can't give you any support with those functions because that's not what I'm using for my own code. If I'm thinking right, NQP mount is just initiating data structure. That's approximately right. So we're loading in the main boot sector and then confirming that the main boot sector is valid. But that's the end of it. We're not actually going to be building up any of the fat stuff once we mount the file. We're really just checking to see if the boot sector has valid values in it. Is C++ allowed? Again, I'm going to say no, C++ is not allowed. You have to use C for this assignment. I want to make sure that everybody's on the same, kind of has the same requirements for the assignment. So I'm not going to allow C++ for this assignment. No, sorry. Do you have to check up the backup boot region? No, you don't have to check the backup boot region if the main boot region is not valid. If you were doing this for realsies, like actually trying to mount an actual proper file system, then you would want to do that. But for this assignment, no, you don't have to worry about that. How are errors supposed to be handled? The errors are supposed to be handled in the form of returning values to the functions that are being called. So assertion failures, if your assertion fails, then you should just fail. If you're returning a value because, for example, somebody passed you something that was null, then what you should be returning in those cases is defined in this IO file. So for example, if someone passed you a value that is null for mount, then you should return something that looks like this inval argument. If you are being passed something that's not a file, so if you're being passed null for the path for the file that you're trying to open, then file not found would be an appropriate response for something like that. What's the purpose of NQP LSeek? So NQP LSeek is going to do what LSeek does, but for the exFAT volume itself. So LSeek itself does get you to move around within the file, but I want this NQP LSeek to do the same sort of thing, but when I call read on byte 1 and then seek 5 bytes forward, I want to then be able to read the 6th byte from the file that we're working with in NQP, within the exFAT volume itself. And that was your question, and I think I've answered it already verbally, so I'm going to skip it. Do we need comments for our code? I need comments for my code, so I think it's a good idea to have comments for your code. Your grader is going to have some flexibility to adjust the score that you're getting on levels based on the code quality that they're looking at, and so comments would be helpful for them to understand what you're trying to do if there's anything that is unexpected that you're trying to do. Yeah. That's a great question, actually. So the question was about error handling and printf and fprintf. I'm going to go back to this example here specifically, and I'm just zooming out so that it's all in one line. That's still not helpful, so I'm going to make it bigger again. If I'm producing a binary file as output like this, and you have printf anywhere in your code, if you're printing to standard output, it's going to mess up the picture. It's going to mess up the binary file because there's going to be random like debugging messages appearing in the middle of the picture, and then picture viewers won't know what to do with that thing. If you want to use printf style debugging, that's super fine. That is super, super fine. But what I would recommend that you do with that is fprintf std error. Print to standard error as opposed to printing to standard output. Printing to standard error, when I do that output redirection like that, is not going to affect the contents of the file for standard output. Yeah. Is the content from week 1 all we need for the assignment? Yes, so we're pretty much done. Anything that we do today additionally for EXT2, it might be helpful, but it's not something that you need for working on the assignment. How is an entry set related to a directory entry? An entry set consists of at least 3 directory entries. The file, the stream extension, and the file name times whatever directory entries. So one single file, so in this case, up here, hello.txt, it has an entry set, and it will have at least the 3 directory entries in it. The thing that's called directory has an entry set, and it will have at least 3 directory entries in it. Hi.txt will have an entry set, and it will have 3 directory entries. Image.jpg will have an entry set and 3 directory entries. This file right here with the long name has an entry set, but it has 15 directory entries in its entry set because it has many, many file name directory entries. So every file has an entry set. Every entry set has at least 3 directory entries in it. How to handle dir entry types that seems irrelevant. So I think, again, please correct me if I'm wrong, but I think that this is related to down here, things like the upcase table, the volume GUID, the text fat padding, WinCE, ACT, the allocation bitmap, you can just skip them. You don't have to do anything with them. They're not useful for us. They are useful for the file system, but they're not related to anything that we're doing in this assignment. So you can just safely skip over those. If the entry type is any one of those, just read the next one and keep going with that. Can we use stdbool.h for Boolean? Sure, yes. I'm actually surprised that I didn't put that in there myself. So yes, absolutely you can use stdbool for Boolean. Are we supposed to make helper function static? I would recommend it. I mean, I do that. If it's a function that's supposed to be private to my implementation, I don't want other people using it, so I'll just make sure that things are static for my own implementations. How do we know which file name directory entry is the final one? The way that we know which file name directory entry is the final one is the stream extension itself tells us how many characters are in the file name. And so we can calculate how many directory entries there are going to be for that entry set for the file name type. Because the file name type has a hard-coded limit of 15 characters, it will always be at most 15 characters per directory entry for the file name. So you can use the length of the file name in conjunction with that 15 to figure out how many file name directory entries there are in a file name. Is it possible for a directory entry file to exist without stream extension or file name? I might be hallucinating. You're not hallucinating, whoever you are. I'll come to you in just a second. You're not hallucinating. There is a case where the file is the last directory entry and the next directory entry is not in the next contiguous cluster. You have to go back to the FAT to find the next cluster in the chain, then you can find the next entry. So that is a situation where what you are observing, again, you are not hallucinating. That's this situation right here. So this is in the assignment description. This is called placement of directory entries. You're observing the situation where the file directory entry for the third file in the root directory is the last thing that's in this cluster. The next cluster then is going to be the data for file number 1, and then the actual stream extension that corresponds to that file entry is in some other cluster. So you have to go back to the FAT, get the cluster chain, go to the next cluster, and then you can continue reading the entry set for that. Yeah.
The original question for that, but yeah, but I'm pretty sure that I was actually on that follow-up. Pretty sure it's not getting correctly, so I might just even say it more doing something wrong. But in a normal case, like, we are expecting it will always, like, we won't have corrupted volumes or anything weird like that.
I'm not going to do anything like that. No, I'm not going to pass you corrupted volumes. This is hard enough as it is. I don't want to mess with you. Defensive programming, that's a good question. Defensive programming for me is like null conditionals in addition to assertions. So like making sure that when you dereference something, it's not going to be seg fault. Prevent seg faults. In this set of volumes that I provided to you, make sure that your code doesn't seg fault with that stuff. So that's also a good question. Will the last entry in a cluster always end with this? So will there always be entry type 00? I'm not sure that it always does. I think it kind of has to though. Like I think it must. I think if this is fully full and this is the last file name, you don't know that this is the last. The only way that you know that this is the last cluster in the chain for the root directory is to go back to the FAT and check to see if the next cluster is FFFFFFF. If that's the case, then you know that you're at the end and there's no more clusters to go to. I believe that I check for both cases in mind, like that I've gotten to the end of the cluster and I try to get the next cluster. If it's FFFFFF, then I'm just going to stop and I'm not going to proceed anymore. But I believe in most cases that it should end as you expect it to this way. Yeah. Yeah.
So the FAT told you to come to cluster
the main boot sector told me to come to cluster 2 here.
Okay, the main
Yeah.
to cluster 2. How do you know to go to cluster 4?
That's where the fat comes in. So with the cluster size, I'm able to calculate how many directory entries there are in a cluster. Because they're all 32 bytes in size.
Yeah.
So I can divide the cluster size by 32 bytes and figure out exactly how many directory entries that I'm going to be reading. Once I've read that many directory entries, then I go back to the fat and I find what's the next cluster after 2. And that then leads me to 4 to continue reading here, the directory entries on this part.
FAT knows it's in 4.
The fat knows what the next cluster is for this. Yes. Yes,
So
yeah.
Is it sort of like an array of each cluster number, or?
It is a giant array, and within that array we have linked structures, like linked lists sort of thing.
Okay.
Yeah, yeah, yeah. The file name. So I'm gonna say something that I think answers your question, but tell me if I'm not answering your question. Each of these directory entries, an individual entry will never span a cluster. It will always be fully contained within a cluster. The file name, so it could be that one file name is here, and then the next file name is over here. That's possible to happen, yes. Eventually, yes. So once you've read all the file names for that file, then the next thing should be a file, yes. That will always be the pattern is always going to be file, stream extension, file name, file name, file name, file name, file, stream extension, file name, file name, file name, file name. The only exception to that is the first n directories of the root directory are all those special cases. Yeah. That ordering is fixed. That is a requirement. Yeah, yeah. No, you don't. So the question is, do I have to worry about direct sector and cluster sizes that aren't divisible by 32? No. They're all powers of 2. They all have to be powers of 2. So they're all going to be divisible by 32 correctly. Yeah. In the mount, when do I return mount unsupported? So as soon as you find something that doesn't work, just immediately return after that. What do I check? So I don't know what the documentation says for the exFAT documentation, but if this is what it says, then yes, but I'm going to have to defer to the exFAT documentation for that. I'm not sure if this is coming through in the stream, but there is like tables moving around above us right now. So the question is about the types here. So these uint types, these all allow us to specify how many bytes the type should take. And so in all the structures that we've got, so all the directory entry types, we know how many bytes each property or each field of this thing is supposed to take. And so these uint types are then being used to specify, I want exactly 4 bytes here, please. Offset T, size T, and S size T. These are being used as part of the interface for like, this is how big an array can be in general. This is a signed version of that so that you can return -1 if there's an error. And offset T is going to be something like, I'm going to add this to an index somewhere. So I want to represent that. In terms of uint types, most of the time you're going to be writing code that's using this because you're going to want to be working with exactly 4 bytes at a time. So for example, in the fat, you want to work with exactly 4 bytes to move around within the fat. So you'll be using those types for that. Having a bit of trouble with the directory entry which says whether the associated file data is a file or directory. So this one, you're going to have to use a mask to determine whether or not it's a file or not. And I believe the mask is 8. Maybe it's 1. 4, 6? I can't remember. 2? I'm going to go back here, and I'm going to go to this part, and I'm going to look up here at the file attributes field. So the file attributes field is what says whether this is a file or a directory. And there's one bit in here that says whether it's a file or directory. And that's in the exFAT specification here. This one here, file attributes. So this one then is describing whether or not it's a directory or not. Is there another one? So in the IO one. Yeah, okay, okay. So in the IO one here, is this the one you're thinking about? Yeah, okay. So this is the one that I want you to basically translate that bit field to. So the documentation for exFAT here says this is set, it's a 1. This bit is set if this is a directory, and it's unset if it's a file. And when you're doing the getDents function, I want you to translate this bit into what this is. So I want you to have a conditional statement that checks to see which one you should be putting into the field here. So this operation that you're doing with this is going to need to be a bit mask. Do we read the full directory entry? You should read the full directory entry from the exFAT types, yes. The one that's defined in nqpio.h is one that you're populating based on the values that you're getting from the entry sets for this. What is uint8t length? This is the number of characters that are in the 16-bit string that you're asking to translate into ASCII. So if it's our readme.md, it's readme.md, so it would be 9 if you're trying to convert readme.md into an ASCII string. I didn't publish any coding standards documentation for this class, no. But like I said, the graders will have some ability to move up and down your code. Your scores for different levels based on the code quality. And I kind of trust them to do that based on, whether or not it's readable or not. Why does directory entry type have a union of bitmap, label, file, etc.? So I'm going to actually ask for that person to go back to what we were talking about, the video that I posted. I realized that I posted a video about this, but in short, I want to be able to read an instance of this directory entry type into a single structure, determine what the type is, and then use these fields to read out what I've got. This structure itself is always 32 bytes in size, and the union will allow us to kind of say that it's going to be one of these 5 things here based on the entry type that we've got. So the structure that you'll have when you're reading this is to read into one of these instances, have a conditional statement or something on the entry type, and then once you know what the entry type is, use these different labels to interpret the remaining 31 bytes from that. Cool, thanks for that advice. Valgrind is a great tool to use. Some people, if someone's immediately shaking their head no, Valgrind is not a great tool to use. I think it's a good tool to use. Segfaults, LLDB is also a pretty good tool for this. Just let your code crash and then kind of go back up from there. Yes, you are using OpenRead and lseek to move around the volume. The root directory. The root directory of the the folder that you submit, yes, is where I'd expect you to put all your code. I'm not sure I understand that question, I'm sorry. For the open file table, yeah, there's a maximum open file table size, and that's defined up here in nqpio.h. So that's max open files is 16 here. Yeah, this is a good question. So if you're trying to list the contents of a directory, you can just safely return a failure. So it's not something that I'm expecting you really to support. You can kind of safely assume that if I'm listing something, if I'm asking for the directory entries for something, it is a directory. If I'm asking you to cat something, it is a file, and it's not going to be a directory. I'm going to point at the 4 properties that are listed in the rubric to say which you should be checking to decide if it's invalid or not. And I think this question was asked verbally, so yes, the answer is yes. Yeah. So the ELF concepts apply. You can read, you can populate structures like the main boot region by passing its address with the read and the size. Yes, absolutely. I'm not sure I understand this question. So the max, what this is supposed to say here is the maximum number of open files. So you can assume that I'm going to call open at most 16 times in the same program. That's what this means. I may have misinterpreted the question that was asked before about the maximum number of open files in the open file table, but that's what this is supposed to be, is the maximum number of files in the open file table. You can assume that I'm never going to call open nqp open more than 16 times in the code that I'm running on your code. If you're in the room and I'm misinterpreting this, can you just quick hands up? Okay. No, I mean, most of this is going to be included with the hand-in submission that you make, so you don't have to worry about this. Yes, you can definitely use memcopy or memset for resetting an object if you want to. Yep. And then I think this is the first question. So awesome. Okay, thank you. That took a long time. That took a really, really long time, but I want to make sure that that I'm giving you a chance to ask questions about this. I will have more time for questions on Wednesday's class. This took the whole class. This took the entire class. It took the entire class today. There's still a little bit of time left, and so I'm still going to do a little bit of stuff, but I'm going to limit the amount of time that I have for questions on Wednesday's class, just to make sure that we're able to make progress with stuff. So I hope that this was helpful, and like I said, I'll give you another chance for questions on Wednesday's class, but let's talk about file systems. So what I want to start with today is kind of like a step back. We dove deep into exFAT almost immediately. We were starting to look at all sorts of stuff related to exFAT, and I want to spend some time taking a step back and looking at file systems overall, and then spending a little bit of time taking a look at VSFS and ext2. So there are many different kinds of file systems. And what I'm going to do right now is I'm going to list a bunch of different file systems, and I'm going to tell you high-level properties of these file systems. But I want to be clear that I'm not going to ask you any specific questions about these file systems. This is for your information only, but this is not something that I care that much about right now in terms of assessing you on stuff. There are many different kinds of file systems, and I'm going to tell you about some of them. This is not a comprehensive list of file systems. There's the ext family of file systems. ext and ext2 were the first ones, and we'll spend a little bit of time thinking about ext2 in this course. ext3 is an extension of ext2. It specifically adds a feature that's called journaling. Journaling is something that we're going to be thinking about in terms of file system consistency later this week. ext4 builds upon ext3, and it adds something called extents. Extents is something that's described in an aside in our textbook. But for the purpose of this discussion, it adds something more than what the other previous file system had. All of these file systems are inode-based file systems, and they are Linux-specific file systems. Other operating systems can use them, but typically these are only going to be present in Linux-based systems. Then, on the other side, there's the FAT family of file systems. FAT, or 8-bit FAT, came about in the late 70s, and this was originally designed by Bill Gates and some other guy who's not as famous as Bill Gates. And then it was extended upon over time to add, as we talked about before, important features like file names that are longer than 9 characters and directories. FAT32 was the last of the older versions of FAT, and it has support for things like file sizes up to 4 gigabytes in size, and that was kind of where it stopped. exFAT extends on this, and it adds support for many things like long file names and much, much bigger files. This family of file systems is typically used on Windows, although it is also kind of just assumed that all operating systems can work with FAT family file systems. So Mac OS, when you plug in a USB drive and it's an exFAT formatted drive, it will typically just work. When you plug an exFAT formatted drive into a Linux system, it will typically just work. When you plug it into a Windows system, it will definitely work. If you plug it into a BSD system, it might work. I'm not sure. I don't really use BSD. NTFS comes after the FAT family of file systems. NTFS adds support for many interesting things, including journaling, which is, again, something we'll think about when we're thinking about the file system consistency a little bit later this week. It adds lots of stuff, and we're not going to dive into this file system at all, but it is what has effectively superseded the FAT family of file systems as the default for Windows operating systems. Apple has its own file system that's called APFS, and this has interesting support for things like, instead of just putting itself on a single volume, an APFS formatted file system can actually span across volumes. So rather than just being one part or an entire disk, an APFS volume can actually be things like, I want to have an SSD or an NVMe drive be the really fast part, and then a 24 terabyte spinning disk be the slow part. And APFS is able to support moving data between these things when it's necessary. It also has support for things like complex permissions and stuff that is not available in things like the FAT family of file systems. And then finally, ZFS has interesting support for things like checksums. This is a file system that I use on my home server for keeping things like family photos. This is data that is irreplaceable. Once I take a photo of my 6-year-old, I can't make that photo again if I lose it. And so I want to make sure that over time, because this is going to be data that lives on my disk for a long, long time, that the data stays the same as it was the day that I put it on the hard drive in the first place. And ZFS gives us the ability to say, like, when a file gets created and written to, calculate what its checksum is, so that MD5 sum, and make sure that when you read it back next time, it's still the same. And if it's not, start reporting issues to the person running the system to say, you need to replace this disk soon because it appears to be failing. BetterFS is the same sort of idea, but for Linux. ZFS was originally designed by Sun Microsystems, which then was bought by Oracle. And that's a long story that we really don't need to get to in this course, but it's a patent-encumbered file system, and BetterFS tries to address some of those things. Yeah. They also do snapshots, yes. And so what that means is that when you have a state of your file system in ZFS and BetterFS, how many of you have actually used version control in practice outside of Comp 3350? Most of you, okay. ZFS and BetterFS effectively have file system level version control. You can take a snapshot of the system state as it's in right now, you can make changes to it, and then you can revert the snapshot back to what it was very quickly without having to do things like use Git as an underlying mechanism. I want you to think about this for just a second. Why? Why are there so many different file systems? I'm going to leave this question for you for a moment. and then give you a chance to read this XKCD that is incredibly relevant. And then I'm going to skip ahead, and what we're going to do is go back to this Mentimeter. So if you left, please join again. I'll leave this up for a second, but the code to join should be on the quiz. Okay. So why are there so many different kinds of file systems? New hardware enables better implementations. Yeah. The very first 8-bit FAT file system, we were thinking about hard drives that were like not even hard drives yet. We were thinking about floppy disks. We were thinking about floppy disks that had kilobytes of space on them. How many folders are you going to put into a disk that has kilobytes of space on it? Businesses want money. Sure, yeah, but I think that's actually tied to new hardware enables better implementations. I think those things kind of fit together here, yes. As hardware increases, companies are going to have to write software to support that better hardware, and then they want you to buy the software that they're writing for that. Different use cases, different purposes, optimizing for specific scenarios, customization of disk SD, optimizing for different problems, yes. Why are there so many JavaScript frameworks? You are tugging at my heartstrings here with this one. Yeah, why are there so many different JavaScript frameworks? When I was doing web dev, I stopped at jQuery. That's where my experience with JavaScript stuff ends. And many of you are just shaking your heads right now because I don't even know where to go with that. React or Angular or whatever. Okay, lots of different use cases. Different architectures, yes, we keep making bigger files for some reason. Yeah, files keep getting bigger for some reason. I'm not sure how many of you back up Blu-rays at home, but Blu-rays are big. They are like tens to hundreds of gigabytes in size. They are really, really big. They are massive files. Different operating systems, yes. Different optimization priorities. I like this one a lot because this actually is a point that I want to make. There isn't, if you aren't using mine, you're doing it wrong. And I think one reason why there are a lot of different file systems is really just because somebody looked at a file system and said, fuck that, I can make a better one. And so they did. Various priorities for different problems, evolving needs. I use ext4, but I have better FS now that I have a multi-drive PC. Yes, same reason there's so many different programming languages and churches. Okay, let's not bring religion into operating systems. People in operating systems have different needs. So yes, there's lots of reasons why people want to have lots of different file systems. And these are all pretty good and compelling reasons for that. So yeah, software engineers are egoistic. So fuck that, I can do it better. Let's have a quick quiz about file systems. Many people are still here, so I'm just going to get started with the quiz. This is kind of asking about some of the stuff that we would have seen in our very first chapter about file systems with VSFS. All right, awesome. So yeah, an inode is fundamentally metadata about a file. We've got an entry set, and our entry sets in exFAT represent metadata about a file. An inode represents metadata about a file. All right. Okay. Okay. An inode bitmap here is this idea of this allocation structure. And so the keywords here are used or not used. It's a data structure that represents whether inode entry 5 has been used by something or it has not been used by something. The bit part of bitmap here says it's literally a 1 or a 0. It's an on or an off. It's a used or a not used. It's kind of like one or the other. I want to give some spiritual credit to this, especially because so many people picked it. But our bitmap, I'm going to give you this. Yeah, our bitmap is data, sure, but the bitmap itself represents the idea of it's used or it's not used. Yeah. The bitmap is metadata. Okay, okay, I'm convinced. Sure, the bitmap itself is also metadata. It's metadata about the metadata. It's hyperdata? No. Metadata? I don't know. I'm trying to be funny and you're all laughing, but it's all pity laughs. Okay, I'm gonna give this to you, but like, sorry about the scoreboard. Yeah. My interpretation here is that the table is the metadata itself. And then the bitmap, you know, a lot of people think it's pictures, and very reasonably so, because that's what Windows Paint is giving us in the end. But I'm going to give this to you. Congratulations. All right, awesome. So this one I'm going to stand by. In this case, it is coincidentally the first block. It's not strictly required that it be there. It's coincidentally the first block, but it's not strictly required that it be there. With VSFS and ext2, yes, it is the first block. With ext2, it's not the first bytes though. It's actually like at some offset into the volume. The best answer to me for this question is that it's generally metadata about the file system. It's metadata about the file system. So I'm sorry again if that one question would have put you up to the top in this leaderboard. Data structure. Okay, here's our last question. Okay, good. Yes. So lots of people are picking renaming a file here. So these other operations here are not necessarily atomic. And remember, the idea of atomicity or atomic here is it either fully happens or it does not happen at all, but it isn't partially going to be in the middle of the state of this thing. Opening, reading, and writing a file are all operations that we might be in the middle of before we stop. We might be in the middle of these things, and it's not necessarily going to make changes to all of these things. Renaming a file is something where we're basically making a link change in the file system with the VSFS file system that we got. Ah, ET. Okay, congratulations, ET. All right, so we spent most of the class talking about this assignment. And so I want to quickly, I've got like -5 seconds here. what I've got scheduled for this week right now is that after today, the plan was to start looking at consistency and redundancy. What I'm going to say for right now is that, and I will make a change to the schedule after class when I get back to my office, I am going to cut this RAID from this week. I'm cutting RAID from this week for now because it is important for me to move on to, it may appear in other weeks. If it does appear in other weeks, I will give you much advance notice about it. For now, I am going to cut RAID from this. The plan for tomorrow is that I want to spend time looking at the ext2 stuff that we were going to do today. On Wednesday, we are going to be looking at crash consistency, file system checking, and journaling. And then it's important to me and us that we start talking about processes on Thursday's class. The thing that we're going to be talking about on Thursday's class is this chapter right here, the process API. It would be helpful if you are familiar with the names of the function calls before you show up to class, but I personally believe that this chapter is better done live and in person to actually see and make observations about the side effects of the functions that we're working with here. So that's the plan for the rest of this week. Thank you all for giving me an extra minute of your time. And